Hello everyone, this is our new video related to unit number 1, that is single degree of freedom system of free vibration. In that we are going to see one numerical based on roller rolls without slipping. So this is the diagram given here. In that, roller is there which is attached to the spring uh, to this fixed support. So this is a spring which is having a stiffness K, and this is the free body diagram. So same diagram is there. You can see there is a roller, and vertically this A point we have considered. So this is the initial position of the roller, and whenever roller will roll, it will cover some angle. So this angle we have considered theta, and this is the new position, that is a dash. So we can say that whenever roller will roll through an angle theta, it will achieve this new position A dash. So initial position is A, and this afterward position is A dash. So also during that, roller has covered x distance horizontally. So whenever roller will roll through angle theta, it will cover x distance. So if you want to relate this x and theta, so we can relate like this: x is equal to r theta. So this is related to your arc is equal to radius into angle. So similarly, x is equal to r theta. In that way we can relate. So for this system we have to find out frequency of oscillation of the roller. So we can solve this problem by both methods, that is equilibrium method as well as energy method, but by the statement in this example we have to solve this problem by energy method. So what is that energy method? We know the principle of energy method, that is total energy. U is nothing but the total energy. Total energy of the system remains constant. So U is equal to Ke, that is a kinetic energy, plus potential energy is equal to constant. In this case, motion is both translatory and rotary. So for this system we can we have seen the statement that this roller is just rolling without slippage, it is traveling also. So in that case, this roller has two motion. As it traveled from this point to this point, so it is a translatory motion, and as it is a rolling also, so it is rotary motion. So we have to consider both the motion, that is translation and rotary, while finding out the kinetic energy of that roller. So kinetic energy will be kinetic energy translation during translation plus kinetic energy during the rotary motion. So kinetic energy is equal to what we know, 1 half mv square, but in our notations that is 1 half m x dot square plus 1 half I theta dot square. So this is for rotation. Okay, so m is just replaced with the I, and that x is replaced with the theta. Okay, so 1 half I theta dot square. So what is I over there? I is nothing but the moment of inertia. So for roller it is mr square by 2. It is mr square by 2. So you can see here this 1 half same, this m is there, x dot square, okay, then plus 1 half again remains same, and this I is just replaced with mr square by 2. So what is that? It is nothing but the moment of inertia of the roller. Then this theta is what? Theta dot is what? Theta dot is x dot by r, right? So this theta dot is replaced with here x dot square by r square, because here it is square. Okay, so hope you got that. Now next is P. What is a P? P is nothing but the potential energy of the roller, that is 1 half kx square. It is generated because of that strain energy of the spring. So 1 half kx square. Now again we'll put both this equation in this main equation, that is U is equal to K plus P. So you'll get 1 half m x dot square plus 1 by 4. How we got 1 by 4? If we cancel out these terms like r square will be cancelled, and this 2 into 2 will be, you will get 4. So in this way 1 by 4 this m x dot square, right? So in this way we will get here 1 by 4 mx dot square plus again this p term, that is 1 half kx square. Okay, hope you got that. Then this 1 by 2, if we add with 1 by 4, you will get 3 by 4 because this term is similar. In this way 3 by 4 m x dot square plus this 1 half kx square. So in this way you will get u is equal to 3 by 4 m x dot square plus 1 half kx square. Now we have to differentiate this equation with the help of with respect to time t. So u is nothing but your constant. If you differentiate, you will get a 0 because differentiation of constant is 0. Then 3 by 4 is again your constant, so it will be taken out. So 3 by 4, then this m is there. Then this x dot square, if you differentiate, you will get 2 x dot, and differentiation of this x dot will be x double dot plus 1 by 2. This k again will be constant. Then differentiation of this x square will be twice x, and differentiation of this x is again x dot. So in this way, if you want to cancel out some terms, then 2 we can cancel. Again this term x dot and this x dot is same, so we can cancel that also, and this 2 can be divided to this 4, so you will get there will be 2 remaining. So 3 by 2, this 3 by 2 will be here, then this m will be here. Then what is remaining? Only this x dot x double dot term. Then this 2 get cancelled out, so k and this x. So in this way we got here 3 by 2 mx double dot plus kx equal to 0. Now we know the fundamental equation of SHM, or fundamental equation of vibration. What is that? It is nothing but your x double dot plus omega n square x equal to 0, where omega n is for natural frequency, n is for natural frequency. So if you want to compare whatever equation we got with respect to this fundamental equation, why we have to compare? Because we have to find out frequency of oscillation for this system. So we have to compare with the fundamental equation of SHM. Okay, this equation. So by comparing this both equation, okay, what we got? Omega n square is equal to 2 by 3 k by n. But how this equation we got? If we divide this whole equation, okay, suppose here it is a 0. Okay, if we divide this whole equation with respect to 3 by 2 m, what we will get? Okay, so this whole term will be get cancelled out, or it will be get divided, so it will be x double dot, and we have to divide with respect to 3 by 2 m. So k divided by 3 by 2 m, it will be 2 by 3 k by m, and this x will be there. So in this way we got this equation. Then we have compared with the equation of the SHM, and if we compare, so this term we can match with this omega n square. So we will get omega n square is equal to 2 by 3 km, and therefore omega n is equal to square root of 2 by 3 km k by m. Okay, and if you want to find out frequency, so omega n is equal to what? Omega n is equal to 2 pi f, right? 2 pi f. So this f will be there. Frequency will be we have to find out. So frequency is equal to 1 by 2f square root of 2k by 3f. So in this way we can find out frequency of oscillation of the ruler. Thank you.